Today's lesson is about significant figures. Significant figures are digits which contribute meaning to a number and its accuracy. The following are the rules for significant figures. First of all non-zero digits are significant. Second rule, all zeros between significant figures are also significant. For the first two rules, it's easy to understand. For example, if I have 2.35, means 3 significant figures. If I have 405.6, then this will be 4 significant figures. The students always have trouble with the third rule. All zeros which are both to the right of the decimal point and to the right of all non-zero significant digits are themselves significant. What's the meaning for this rule? Let's define the all zeros before non-zero digits are leading zeros, like these 3, they are leading zeros. These leading zeros are not significant figures. Then we call zeros at the end of a number that's trailing zeros. If we have a decimal point, then these trailing zeros are significant figures. For these two trailing zeros, since we don't have a decimal point, then it's not significant figures. In other words, trailing zeros, whether it's significant figures or not, depends on the decimal point. For example, we have number 0.00108. This is leading zeros. It won't count as significant figures. Therefore, we have 3 significant figures for this number. For all zeros, only when 0 are leading zeros or trailing zeros, there is a chance of not significant figures. So when you figure out how many significant figures for a number, you need to pay attention to leading zeros or trailing zeros. That's all. The zero which is between 2 non-zero digits definitely will be the significant figure. For example, like this 0, definitely count as a significant figure. For second number, these 3 zeros are leading zeros, not significant figures. So we have 1, 2, 3, 3 significant figures. For 0.00200, we have leading zeros, and also we have trailing zeros. For trailing zeros depends on the decimal point. We do have decimal point here. So these 2 zeros will be counted as significant figures. So we have 3. For 19,000, we have 3 trailing figures. Since no decimal point like this, it won't count as significant figures. So we have 2 significant figures for this number. This will be 4, definitely. These 2 zeros between 2 non-zero digits will be counted as significant figures. For this number, we have 1.00106. We count all these as a significant figures. So we have 1, 2, 3, 4, 5, 6. For last one, this is a trailing zeros, and we don't have a decimal point, so it's not. We only have one significant figures. Let's talk about rules for rounding off. If the digit after the 1 being rounded off is less than 5, we round down. If the digit after the 1 being rounded off is a 5 or more than 5, we round up. In IB Math, DP stands for decimal places. SF stands for significant figures. Now let's go to guided practice 3 about rounding problems and significant figures. For number 1, round off to the nearest 100. So we will change last 2 digits into 00. Then we cross out this number. The first number you cross out, you got to do round up or round down. For this 7, we need to round up. So we change into 100. Let's go to B. Still change 2 zeros for last digits, then cross out. Then you need to check this 3. We know 3 is less than 5, so we round down. That is 400. For C, I need to change into 2 zeros for the last 2 digits. Cross out. This 6, we need to round up. So change into 4800. For number 2, round off to the nearest 1000. So we change last 3 digits into 3 zeros. We do 1, 2, 3, cross out. This is 7. You need to round up. So we have 1000. For B, cross out last 3 digits, change into 333. Then this 5 round up. That's 6000. For C, change last 3 digits into 000. This 2, since it's less than 5, so we round down. That means 434,000. For number 3, write correct to 2 significant figures. For this kind of question, you have to work out from the front. Count from front 2 significant figures. Then cross out rest of numbers. For example, like A, we need only 2 significant figures. So these 2, we stay. Cross out 6 and 0. Then change into 2 zeros here. Then check this 6. Since it's more than 5, we need to round up. So we get 1800. For B, we have leading zeros. Leading zero is not counted as significant figures. So we only keep these 2. This 9, you need to round up. So we get 0.041. Let's go to C. From front, we need the first 2 significant figures. Cross out 4, 6. Since this 4 is less than 5, so we just round down. Therefore, we have 3.0. Make sure that When you change into two significant figures, the value will be very close to each other. Like 1760 is very close to 1800. Some students just cross out 60 wrong into 17. Definitely it's wrong. So always check after you change into specific significant figures. Are they close? For number 4, write correct to 3 significant figures. For A, we know this bar meaning. That's 0.63663. We need to change into 3 significant figures. So from front, these 3 is significant figures from the front. So cross out this. These 3 will be round down. So we have 0.636. For B, the first 2 leading zeros is not significant figures. So we get started from this 6. I need 3 significant figures. This 1 will be round down. So we have 0.0637. For C, we need 3 significant figures from the front. So we have these 3. Then cross out the 8. You have to change into zeros. But this 8, you have to round up. Therefore, we have 257000. Guided practice 4. The speed of sound in air is given as 300 meters per second. How many meters does sound travel in air in 1 hour? We know that 300 meters per second. We also know that 1 hour equals 60 minutes. Equals 36,000 seconds. So we multiply by, here's 1 hour, 36,000 seconds, so that we can reduce here. We do multiplication. You will get 108,000 meters per hour. That's for A. For B, we need to correct the answer to part A to 2 significant figures. For 2 significant figures, we need to get a number from the front. When we have 108 4 zeros, we get started from front, these 2. So cross this out. This 8, you have to round up. So change all into zeros. So that we will get 110000. This will be the solution to this question. For 2, we need to express this answer. That means 108,000 in the form A times 10 to the case power. A is the value between 1 to 10, and K is integers. This is integers. So we get from the very back, we count the decimal position. 1, 2, 3, 4, 5, 6. So we can write 1.08 6.8 times 10 to the 6th power. Now let's talk about percentage error. Error equals VA minus VE. VA means the approximate value. VE means the exact value. So your approximate value minus the exact value will be the error. So error could be negative. For this symbol, we call percentage error equals your approximate value minus exact value over exact value. Remember that it's an absolute of the value. Then we multiply by 100. In other words, the percentage error always greater than 0. It's a positive number. Find the error, percentage error, if you estimate the following questions. For A, the mass of a brick to be 5 kilogram when its actual mass is 6.238 kilogram. So this is the exact value. This is the approximate value. Since the error equals approximate value minus exact value, so we have VA minus VE. That is 5 minus 6.238. It will be negative 1.238. Therefore, the percentage error equals absolute value of the error, that's 1.238 over exact value, that's 6.238. Then you multiply by 100. Then put into calculator, you will get 19.846%. For IB math, you always round your answer to the thousand. Now let's work on B. The perimeter of a property to be 100 meters, while its actual length is 97.6 meters. This will be VE, that's exact value. And 100 will be the approximate value. So for error equals VA minus VE. That is 100 minus 97.6. So you get 2.4. For percentage error equals 2.4 over exact value, that is 97.6. Then multiply by 100. You will get 2.459%. For C and D, you can work on this by yourself. Guided practice 6. Anthony uses the formula P equals 27Q over R plus S to calculate the value of P when corrected to 2 decimal places. Q equals 0.89, R equals 1.87, S equals 7.22. He estimates the value without using a calculator. Write down the number Anthony could use in the formula to estimate the value of P. Without using calculator means he round all the value into integers. For Q, it will be 1. For this R will be 2. S will be 7. This is the solution for the first problem. For Second question, work out the estimate for the value of p. Basically, we just need to plug into this formula. We have 27 times 1 and 2 plus 7. 27 divided by 9, that equals 3. For B, a calculator is to be used to work out the actual value of P. To what degree of accuracy would you give your calculator answer? It will be 2 decimal places. Give a reason for your answer. Because they are given 2 decimal places for QRS. We are talk about the degree of accuracy. Normally means how many decimal places or how many significant figures. So you can also say that I will give my calculator answer 3 significant figures.